The topic of this tutorial would be regression analysis. Now, in statistics, there are two kinds of regressions. One is the linear regression and one is the non-linear regression. So, okay, this is what regression analysis is. Regression analysis includes any techniques for modeling and analyzing several variables when the focus is on the relationship between a dependent variable and one or more independent variables. And as we discussed earlier, that it is of two kinds. So first of all, let us start with linear regression models. So in statistics, linear regression models often take this form: y equals to beta naught plus beta 1 x1 plus beta 2 x2, where beta naught, beta 1, beta 3 up to beta n are the coefficients, and x1, x2, x3 are your variables, plus epsilon, which is your which is the error which you get. So so this is the terminology. We have the linear additive straight line models, we have polynomial models, we have Chebyshev orthogonal polynomial models, we have Fourier trigonometric polynomial models, and I mean, these are further examples: the hyperplane models, the pairwise interaction models, the quadratic models, and the pure quadratic models. Okay, so after this we come to multiple linear regressions. These multiple regression models are useful for three main things. We can understand which terms have greatest effect on the function. We can find the direction of the effects, that is the signs of your beta j, that is the coefficients, and we can predict unobserved values of the response of the function yx for new values of x. Okay, next comes robust regression. Now, robust regression works by assigning a weight to each data point. Now, this weighting is done automatically and iteratively using a process called iteratively reweighted least squares. Now, if the distribution has errors in asymmetric or prone to outliers, model assumptions are invalidated and the parameter estimates confidence intervals, and other computer statistics becomes unreliable. Now, we use the statistics toolbox function robust fit in such models. We have this. After this, we have stepwise regression. It is a systematic method for adding and removing terms from a multilinear model based on the statistical significance in a regression. Next would be ridge regression. Now, this is used in situations of multi-collinearity can arise. For example, when data are collected without an experimental design. So we can have collinearity in several ways. We'll have multi-collinearity. Now, ridge regression addresses the problem by estimating regression coefficients using this formula that we see here, and k here is the ridge parameter and L is the identity matrix. Okay, after that we come to partial least squares. Now, partial least square regression is a technique used with data that contain correlated predictor values. Now, this technique constructs new predictor values known as components as linear combinations of original predictor values or variables. There are also these polynomial models for regression. They have this advantage of being simple, familiar in their properties, and reasonably flexible for following data trends. Then we have response service models, in which we have multivariate polynomial models. They are multivariate polynomial models. They typically arise in the design of experiments where they're used to determine a set of design variables that optimize a response. And finally, we have generalized linear models. Linear regression models describe a linear relationship between a response and one or more predictive terms. Now, a special case of nonlinear models known as generalized linear models makes use of linear methods. We have this multivariate regression in which whether or not predictor x is a vector of predictable predictor variables. Multivariate regression refers to the case where response y equals to y up to ym is a vector of m response variables. So these were the several methods and models which are used in regression.